All right, should be live. Should be. And this video should start playing. Should. Maybe. Yeah, I don't know why it's not doing that. I have to reload. Nope, there it goes. All right. This video should start playing. All right, there we go. So everything's working fine. Probably, mostly. So I do have a drawing enabled. So lensing is probably going to be the subject. Probably. Lens. Anyway, uh, this is no doubt mindless marbles, but we'll get to this other crap first. So no one, nobody says hello. Well, whatever. Fuck that. So then some weirdo, AW, writes this whole long, preposterous pile of shit. First about he quit smoking and blah, blah, blah. And like I should care. Again, I'm not asking for advice. So you don't like nicotine and you only smoked it so you could smoke CBD. I don't know what CBD is. I know what marijuana is. I don't know. Is that why he was, which always seemed a silly thing to me anyway. I mean, I smoked pot before I smoked cigarettes. But anyway, who cares? So all this crap, blah, blah, blah. I hate tobacco, blah, but who cares? Okay, fine. You're over your attachment to tobacco. Fine, good for you. Happy for you. Blah, 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 blah. By the way, Ed Chamari, I don't know, you are probably not right as I see it. So again, this guy thinks I'm Miles Mathis, apparently. And so he starts talking about Miles Mathis's crap and, how he should continue painting but shouldn't do nudes. And I'm just like, fucking, what the fuck? Look at all this crap. And he doesn't even pay enough attention to know I'm not Miles Mathis. What a fucktard. So anyway, I mean, just people are so fucking stupid. So this Bravada guy, who it's got to be mindless marbles, right? Who else would do this anal crap again? Here are pictures of people showing you the correct lens shape. So this first link I couldn't get to work, and so this second one I don't remember what the fuck it was, but it wasn't at all interesting. Um, Here is something being done with it. So here's actually something being done. There's nothing being done. They're doing a lensing experiment on a table, and he thinks that's the same as gravitational lensing. So anyway, here's the pages that'll go to those, and here he says, "Here is the lens creating stretched images, just like I said it would do. So it would do." Yeah, because what you went to the page before you had the conversation. Um, and this is so they made a plastic lens and they shaped it. Yes, it's sort of shaped correctly, but it's still wrong in the sense that it's got the Einstein cheat in it. So unlike, you can take a lens. See, this one's flat on one side, and all of the lens shape is on one side. So it's the same as a convex lens. It's in the same. It's just that the slope is more because it's all on one side. So it'd be the same as a regular lens with just half the slope and then half the slope on the bottom. But it does the same thing. So you can do a lens. You don't have to do it equal on both sides. You can have one side flat and it does the same thing. It's just you change the angle. So this angle on this lens is the perversion where they took away the inverse square law and pretend that light doesn't know where it is. Pretends that light thinks it's in the gravity twice as long because it thinks it's in twice as long. Therefore, it isn't in gravity twice. It gets twice as much gravity. Therefore, you don't get rid of the inverse square law. So the real slope should be much more severe. So first off, it's, okay, we have to use your dopey assumption that somehow photons are special and they don't act like all the other stuff in the universe, and the inverse square law gets to get broken for photons in this one circumstance. Photons that aren't broken when they're magnetism or when they're in some other form, and all of a sudden the inverse square rule still affects those forces, but somehow it doesn't affect light. So there's another contradiction between Einstein and quantum mechanics. Quantum mechanics doesn't have you're exempt from the inverse square rule for photons, for things moving the speed of light. So anyway, so here's the page. Let's see if there's anything else to read here. All right, let me post these links. Well, I wish you would post them as links, not as crap that I have to put in 6 dots to fix. I don't know. What's your problem? You can't post a link? All right, at 4235, you say others should be able to concede that the textbooks draw it the wrong shape. Now, that's a simple statement. Either it's true or it's not true. It's not just the textbooks. I stated every single presentation of lensing is always shows the wrong lens. Always. And you trace the image of the convex lens with your arms. Yes. That's right. That's what I say. Now, you want to show me some evidence of otherwise? Can you provide me with a textbook that draws it as a convex lens? Can you show me one that shows it the correct lens? I'm saying every image. If I Google it, if I Google gravitational lensing, you'll see the images with the lens. You're denying that simple truth, you fucking cunt? An incredible denial. Can you back up your assertion that they draw it as a convex lens? I don't have to. Google it. I've already shown it. It's in every single video that describes gravitational lensing. Every single one draws the wrong lens. Every single one. I've never seen one drawn correctly. You also claim in that time frame that NASA and presumably articles, I don't know what that means, and presumably articles draw it the wrong shape. Yeah, I'm telling you every single one I've ever seen. Every single one. Can you back this assertion up? So again, yes, I'll Google it for you. Is that what we have to do? I have to Google it for you? Is that where you want to go that low? Do you want me to do that and just point to every single image being wrong? Amazing. I went through the trouble of providing links and figures where they draw it as an inverted concave lens. And you'll see the website. It's not a common website. Can you try to make the same effort on your side? If not, you can make a retraction. I'm not going to retract anything. It's micro lensing. It has absolutely nothing. Okay, let's understand. This website is about micro lensing. So it's right in the title. Well, there's also got gravitational lensing right here, but it's a description of micro lensing. They're talking about suns lensing other suns. This has nothing to do with the lensing images of the Hubble telescope. Nothing. All right, so let's go Google gravitational lensing. This is the Wikipedia page. I'm sure we'll have the wrong lens on this page. Let's see. It should be on here. There's the lens right there. Let's see. So we can make that image bigger. Let's see. They don't have the lens in the image. Okay. So they don't have a lens in this image, which makes it even more confusing, right? I mean, you can't even tell what's going on because there's no lens in the image. Let's see if we have one here. Oh, they're fake simulations. So again, we have real things with real shapes. Look at the shape of this thing. It has obvious light and dark spots. It has obviously a galaxy that's been stretched. You can still see its form and substance. There's not just a blob of light, which is lensing is supposed to just create. So, all right, we don't have an image. So let's go to Google. And we'll prove the point. Google Maps. I don't want Google Maps. I want just Google. Thank you. Just give me Google. Thank you. I don't even want Google, actually. All right, let's just go to images, and we should have a ton of images. Should be. All right. that one doesn't have a lens in it either. Maybe they're getting sneaky and they're taking the lenses out when they draw the image. They're still obviously converging the light. So this is obviously, even though the lens isn't in the image is clearly showing more bending on the outside than on the inside. So it's more bending on the outside. Where the gravity is the weakest, they're putting a lot of bending. So see if we can find a better image where they actually draw the lens. See, is this one got a lens in it? It doesn't look like it, but again, converging. Light going diverging and then converging. Okay, the only kind of lens that's going to do that isn't a gravity lens. The one that bends more on the inside isn't going to do this. The bending, you need more bending out here than you need here. Yeah. Let's see. I mean, I could play the PBS video. I could play Veritasium. I don't know if Thunderfoot's made a video that has a lensed image in it. What do we got here? Clearly, the implication again: light spreads. Light is getting converged to a focus. It has to be done by a lens that's the right shape. Yeah, they don't have the standard drawing. I know LIGO used one too for something. I don't know what they did it for, but for some purpose. And they had clearly the shape of the lens in the drawing. Yeah, I'm just surprised that there aren't any with the shape of the lens. They just show the magical bending. I'm just saying this, you can't bend this way with the wrong shaped lens. So it's just got to be understood. The strong bending happens close to the gravitational body. Further away you go, less bending. This can't work. Nope. Yeah, I'm really surprised. I guess I should have gone with web pages. But again, you'll see the same thing. The lines are always spreading out, diverging, and then they converge. And you're not going to do that with a gravity lens and such. Well, anyway, I mean, I guess it's good that the images aren't as bad as I thought, in the sense that they don't bother drawing the lens anymore. Still nothing. But all these fake images, this is what would be if, but, just fake. Oops, I didn't want to do that. Pick up where I left off, hopefully. Send me back a bit. Yeah, that one doesn't have the shape either. All right. Well, I'll concede. I thought there would be more drawings, and there aren't very many drawings of lensing. But again, you can see the shape is clear. It's what a convex lens does, not what a concave lens does. That's about it. Yeah, I'm not going to bother with the more part. All right. So let's go to the page and we'll deal with his evidence of nothing. So again, if he wants me to play the PBS image, I can do that, if that'll prove the point. And the other talking heads. I mean, I know it was in Degrassi Tyson's TV show, Drawn the Wrong Way. All the talking heads do it wrong. All right, so this is just a camera, which isn't very interesting, and a little light, okay? And then they're going to put this lens in the way. That, again, isn't the inverse square law. It's just the R law. And this is what the little light looks like at different locations, moving it across the background. Now, I don't know what all this stuff is, these hazy images, pixelated and whatnot. But we could just bounce through these images. This is image number 2, I think, or 7. Okay, well, let's see what image number 6 looks like. And such. All right, so this is what it looks like as it goes across. I don't know why the color changes are happening, so I'm not going to read the whole page. But clearly, this isn't the same distance relationship and size relationship as galactic lensing. Galactic lensing takes place over billions of light years of distance. This has nothing to do with galactic lensing. And I'll jump to 5. See if that's a good one. I wish I could have just provided decent links. So here's distortions again. I'm not going to bother to look up what kind of movement they did or tilting or some other thing. But these look nothing like the lensed images you get from galactic lensing. And next. It looks the same almost. So this is the stretching he says he was talking about. Again, we don't know what the focal lengths are here. At least I don't know. No demonstration that this collects more light and then brings it to a focus. So, and again, why move things? It's just complicating the story, just because we know the stuff in the galaxy isn't doing this moving stuff because they're all time exposures. So I don't know what this is, what they was looking at, a collection of dots. So which way were they moving, up and down? If they were, I don't know. So obviously I don't even know if they were in the right sequence, those colors, but whatever. We just don't have any. But this doesn't demonstrate, again, this isn't how they describe how galactic lensing takes place. It's not in any of the videos that explain galactic lensing. So show me a video somewhere that explains it using this lens. And he won't be able to do that. Show me a video that has the right shape lens. Just one video on YouTube on the subject of galactic lensing that has the right shape lens. I mean, I guess that's the thing to do, is just look it up on YouTube maybe. And we can just go by we should get a good image of the lens shape doing that. So the lens is in this one. Can't see it very well, but there's the wrong shape lens. All right, see, these are some of these images are the same as the ones from Google. Obviously. Yeah, unfortunately. Let's see. Yeah, they got the light bending again, more on the outside, less on the inside. This is the blender images. They have nothing to do with a real image. Again, I don't know what this is, but this certainly isn't the right shape. This bent space isn't the right shape for the lens. Look at this one here. There's a clear example. Regular convex lens. Let's see, anything else? Where's this drawing? Well, too hard to see that. I mean, this compound image is almost funny because it's such a mess. But anyway, you can clearly see lines diverge, lines converge. That's not what a gravity lens is going to do. Let's see if we have anything else. Yeah, it's just the bad luck of the images. We're not getting the best of the images. Where they have the lens drawn there. Well, just saying that we haven't found any that have the right shape. that can be said. Again, bending the wrong way, again, bending more on the outside, less on the inside. Completely backwards, more on the outside, less on the inside. Gravity works exactly the other way around. And such. Well, that's all we're going to get, I guess. All right, so we'll go to the drawings and just say the hell with it. That is. A lot of crappy videos on the subject of lensing, actually. Yeah, they get crappier and crappier here towards the end. Eek, looking less and less relevant. Let's see, what does this say? Gravitational lensing, part 1.
Hey everyone, welcome to another episode of Conversations with an Astrophysicist. I'm your host, Scott Lewis from Know the Cosmos.
Well, interesting. Live rooms, anyway. Oh, come on, jump ahead. I don't want music. Oh, I went to Magnetism Matters. I didn't do that.
Blowing material out of the central regions, and then warming the intergalactic medium, enriching that their surrounding. Finkelstein. There appears to be fewer than you expected at redshift of 10.
Okay, well, here we go.
If you integrate
here we go.
20
Whoops,
lens images of 8 galaxies at lower redshifts. And so the key takeaway from this plot,
there we go.
At higher redshift, then you'll.
So again, we have all this, again, the wrong shape. Stuff goes the more bending further away from the gravitational object. Doesn't make any sense. Yes, I don't know why it's a different video. If there's any other images, yeah. No. All right. Go back one more and see.
Hey everyone, welcome to another episode of Conversations with
a giant ring that just goes all around. So it's a really perfect alignment. Now you have a
I brought
one glass.
Too.
You brought prop.
Okay, right. So again, you can see how there's not a perfect alignment in the first place. So the symmetry is way off. There's not equal distances. It's all kinds of problems with this image. And her claim is, yes, it's right behind. So the other object that we're seeing, the ringed object, is actually an object behind this object that we wouldn't be able to see at all if it wasn't for the lens. And we have no explanation of how a concave lens produces this ring at this distances. So there's no explanation of how that's possible. And the more important part is how it would maintain this part of the image, the thickness of the image, because that's the part that would get totally destroyed because the inverse square law doesn't bend the light at the right amount as you travel distance. So it's not going to create a rational focus. And certainly not for those kind of distances. I mean, this would be hundreds of light years across this image, thousands of light years across. Very big image created, and lots of detail, lots of pixels, lots of photons, and they all have to be bent just the right amount to get to our eye, and they're not going to do it with that lens. And so this is all just the standard propaganda. Let's just to see if they use one of the images, that show the lens. So apparently it's just physicists. Oh, well, physicists talking to physicists, astrophysicists. Full of shitters talking to full of shitters. Not too many views for them either, apparently. Even the physicists can't get anybody to listen. All right, so maybe I'll watch this later. Maybe I'll subscribe. Anyway, all right, so back to where was I? Yeah, so I'm just making this simple argument that it's misrepresented lensing, as if the lensing is happening by traditional lensing mechanisms, big lens. And it just can't, it's not represented accurately. So they don't point out first how bad a lens shape the inverse square law is. Let's see, where's the other video? I'm pretty sure I opened it. Yeah, pretty sure it's here. Camera should be here. Oh, there we are. All right. All right, I will attempt drawing something. We've been over it before. So the trick is that every object, so let's say you have an object. And as I was saying before, when two things move away from each other, they don't really change size. So they really are the same size. If they were the same size when they were next to each other, when you move them apart from each other, they really don't get smaller. And so if the lens, if it was a galaxy and you were going to lens another galaxy, the light would all be coming in parallel. And it wouldn't be doing this because it's small. It isn't really small. It's the same size as it was. And so the light's all going to come into this other galaxy, or say if it's a sun and a sun. So that's where the micro lensing comes in, because that's what they were talking about on that website. So that really has to do with objects that are the same size and what happens to the light. So when it's coming in parallel, there's still the argument that to see this as it is, that means all the light has to be bent at a specifically declining angle, for you to see it. The stuff on the outside does have to get smaller because this is a big sun and you're going to see it with your little eye. So it's always going to go to your tiny point that is your eye. So your eye is always smaller than all of these things. It's smaller than this lens. So this lens is collecting light from something, and it's usually, to enlarge it, it has to collect light that's diverging. So the idea is the light's diverging to get to the lens because the lens is bigger. Okay, so you can kind of get the idea that the thing is this big, the lens is this big. The light the lens is capturing is light that's diverging, separating, spreading. It's not light that came off parallel in straight lines. And then the light's going to be rebent proportionally, a proportional amount to recreate a focus, to shoot all the light to one point. And so obviously the light from something directly behind the lens would be, the middle, would you want that to not get bent at all? And it gets bent more and more as you go further out. And gravity does exactly the opposite. So this traditional notion of magnification can't possibly happen with the wrong lens. Certainly not in the Einstein ring kind of sense. And it doesn't seem logical to magnify and do that. So the micro lensing is more like the objects are the same size. So the lens is the same size as the object. And they used the lens that didn't do the same shape. And so I can't figure out, but still the point is that obviously the light that comes from the middle would be bent a lot. And the light that comes out to the edge wouldn't be bent at all. So it couldn't possibly focus something behind the other object. It would focus it at some other point, a point that you wouldn't see it. How to say that? You'd see it in a wrong location, so that part it would be correct. Oh, I bent the light the wrong way. Obviously, this bends this way. So the light. Okay, so let's see how much the light bends the most here, and it bends the least out here. And so this and this, these two lines can't possibly ever converge. I mean, they're going the wrong way. How could they possibly be brought to a focus? Yeah. So you'd never be able to resolve an image. And so all you could do is get random pieces of light that would come in at different angles, and you'd actually bend them the right way to get to your eye. But there would just be little bits of light from different places coming in at strange angles and hitting the lens at the right place to bend it to your eye. But you couldn't ever resolve an image with this lens. The shape or form or the character of something would always be destroyed. So you couldn't see individual stars of the distant galaxy, for example. All right, so that's probably enough on that. So the weird thing about this whole subject is when you think about it, is there's no real easy way to draw this. So I guess I'll just say it in a way. Everything casts an image. So everything that's, exists and light's bouncing off of it, every bit of it is a single little point. And each one of those little points shoots light in all directions. So there's an image everywhere. I mean, there's one here, and there's one here, and there's one everywhere at different lengths and distances. There's image everywhere and made of different, these images would be the same. Let's say this image would be the same as this bigger image here. Those are the same photons. So, this image would be the same as, well, I should have drawn it bigger. But, you can have a bunch of them overlapping at different sizes, depending on how far you go. And so that's what gravitational lensing is supposed to be taking advantage of, is that there's a smaller object far away, and you're basically trying to capture all of the photons that it released in this cone that didn't hit something. And clearly there's not supposed to be anything in the way, because we'd see that. So there can't be anything in the way, generally speaking. Can't be much in the way. And then the idea is that we refocus the light. And I just don't see how. Draw me the picture, mindless, of how you can do that with this wrong shaped lens. Explain to me how a lens, shaped this way, does this, takes this image that's being projected in all these locations at these different sizes, and ultimately this big size. And then, part of the point is too, though, is the lensing images we're seeing are pieces here. So it's like a clump of the lens here. But that clump of the lens is got to be understood to be, that's where the image is showing up, where all the cone converges. So if I was to draw, this is looking from going towards the lens, let's say. And so you had an image here, and you projected a much bigger one here. So just imagine this one is much bigger. This is a galaxy. And so the light's been spreading from this image, and it's cast on this. It's there to be focused or not focused. if it isn't focused, that is, so we're looking from behind, and then the projection will be to our eye. So our eye is going to take what's inside that lens, and it's going to, the light is now converging towards the eye. So the light diverged to make the big image on the galaxy. So let's say you had a star and you had a galaxy, and the galaxy was going to lens the star behind it. So the star projects the big image, which it's projecting everywhere. I mean, there's this big image over, there's even a bigger image way over here. Okay, that if this image kept going without the lens would be even bigger image. So you're projecting a big image, and when you project it into this lens, so if the lens isn't there, the image still goes places. But with the lens in the way, right? But because the lens is there, now it's going to change where those photons go. And so it's going to take photons that would have gone this way and would have gone this way, and it's going to converge them onto this light, this eyeball. And so, how do you do that with a lens that is bending the light more on the part that has to bend less, and bending less on the part that needs more bending? Is still the argument, because that's what has to happen. I mean, it has to bend more out here and less in here. No, that's not the best drawing, but it's enough. So anyway, so instead of just admitting the point that the evidence for gravitational lensing is really weak, in the sense that, first, the Eddington experiment's never been repeated successfully. Never done the first time successfully, actually. Images are terrible. And those are quality ones on glass plates. They don't even do that anymore. And that's with us understanding that we just had the solar eclipse last year under perfect conditions, and nobody repeated the experiment successfully. I mean, I pointed to the one guy who claims he did, but he has crappy images, and it's all a synthetic comparison. He didn't take, he didn't make actual comparisons to images 6 months later. It's just all star charts. It has nothing to do with real images and measuring where stars should have been in real images. It's not the Eddington experiment. So with all these big telescopes, all this other stuff, nobody did it. Nobody repeated the experiment. And as I pointed out, the Hubble telescope's never done anything interesting either in terms of attempting to look in the area of the sun. So what's the other point? And the rest of the rest of the story is about the galactic lensing. So we never have a repeat of. We haven't seen anything. We have no images of anything ever being lensed by the sun, and we have these galactic images. These, whatever you want to call them, these really huge lenses. And they don't fit the math. They're not symmetrical. Gravity is always symmetrical, especially big gravity. The bigger an object gets, the more likely it is to be perfectly round. That's one of the rules. So really big gravity would be really round gravity. And especially gravity has to be strong enough to bend light. I mean, you could have gravity from a clump of galaxies, but their density is so low compared to the empty space between them that they would have a tiny amount of gravity. It wouldn't be nearly enough to bend light. And again, you have to bend it rather severely, if you're going to be honest, because the galactic cluster All right, so a cluster of galaxies is gigantic compared to an individual galaxy. I mean, it's a huge difference in size, and so the individual galaxy has to be, it has to be enlarged. Well, it doesn't have to be enlarged that much because, frankly, in the lens, just because it'll end up being the size of one of the other galaxies, which works both ways as an argument. It's an indication that the lensed object is not something other than the rest of the stuff in the cluster. But it's clearly that you could explain that it just, for whatever reason, an explosion happened, it got blown over here and misshapen, because it's the same size. So in a sense, these would all be parallel rays, because the galaxy is just taking up one tiny portion of the lens. But see, they move it all the way around here. They do the Einstein thing. So that's where it breaks apart, because it can't do both sides and be the wrong shaped lens, because then it couldn't bring them both to the same focus. All right, well, that argument gets more complicated, so I'll let that one go. But anyway, the simple argument is they got really weak evidence, and instead of just conceding it, he does this, which is to pretend that all of the talking heads of science and all the professors and all of the media on the subject of lensing does it with a concave lens, or a lens of this shape. And they're totally honest about the fact of how that lens doesn't collect light and bring it to a focus, when they're totally not honest about that fact, and they don't represent that truth in any way at all. So instead of just admitting the evidence is weak, which it is, incredibly weak, and that it's got a lot of misrepresentations in it and things that aren't entirely accurate, instead of just admitting it's not well documented, not very accurate in the statements made, the theory has a lot of contradictions in it, that there is a lack of precision, the symmetry isn't very good, and it should be really excellent, all that kind of stuff. Instead of just admitting it, he just plays this game, deny it, and show one example of somebody using the right kind of lens, but for a different kind of lensing. Okay, again, the website is about suns lensing other suns. So the light comes in parallel to the sun and is somehow brought to our focus is the object. But those are usually objects that aren't right behind something else. All the galactic lensing, the object is stated to be behind the galaxy you're trying to look at. You can't see it, and you see the object in some other location. Because of this bending, it has to bend it to see it in another location. All right, well enough. So, like I say, won't admit the simple truth that the evidence for photons being bent by gravity is still incredibly thin, weak, almost non-existent as hard evidence. It's got huge problems either in the mechanics of it, the math of it, and the fact that we just don't have it. We don't have images of it. We don't have pictures of it. We don't have any hard evidence of it. So anyway, see if there's any comments. And I might do a room tomorrow morning at 10 o'clock because the CP whatever thing isn't going to be doing their room, so I figured I could do a room maybe, but I don't know if anybody's going to show up from there anyway, so that's probably a useless redundancy. Useless is the key term here. Everything is pretty much useless. All right, now I know I popped out the chat. I know I did. I did it on purpose. I saw myself do it. Where the hell could it go? Yeah, chromium. That ain't it. That sure as hell ain't it. Is it? No, that's the stupid hide thing. Yeah, it's missing again. That is weird to me. And I can't ever. I don't know why it would. I might have closed it. Maybe I closed it. I don't think I did, but let's just assume that I did. All right, so let's see. Not much here. Let's see. Oh, Jesse. Yeah, there's a few comments. Let's see what they say. What do you think about the role of computer simulation in science? I think simulations are fine, but garbage in, garbage out, right? So what's, you could simulate Huygens. You could simulate Heisenberg. What's the point? It's rubbish. I'm not sure what your point is about convex versus concave lenses. Well, it has to do about magnification and how you create a focus. For one thing, concave lenses cause light to spread outwards, which gravity lenses don't do. Well, then you just proved my point. Gravity is a concave lens. It bends more in the middle, less on as you go further out. The angle, it bends less on the outside. It's got to bend more on the outside. And nobody says they do that. So you just don't get it. Quite obviously, you don't know what you're talking about. No, quite obviously, you don't. I mean, you don't understand well, I'm not going to redraw it, but you don't understand that a standard lens bends light more on the outside than in the middle. That when you use a magnifying lens, that's what it's doing. It's bending the light out here more and bending the light less right here in the middle. Shit. So fuck you. Yeah, it's not to scale. Okay. Maybe if you had an anti-gravity device, what a waste of time. You could create a concave gravity lens. More nonsense. But in any case, the point is moot since you're deliberately misconstruing what scientists say happens. So I'm arguing then I can say that you're deliberately doing that then. So if you're saying I'm deliberately doing it, when I'm making the honest point that we know what this lens does. All right, it takes light that's diverging and reconverges it. That's what this lens does. Now you explain to me how a concave lens does that. All right, but in any case, since you're deliberately misconstruing, okay. So I'm just saying. So I can accuse science then of deliberately when they misrepresent, when they show the image without the lens in it, but they show the light that diverges out here bending more. Okay, than the light going through here, which bends less. So when they do that, they're deliberately doing it. Okay, they're deliberately misrepresenting the truth. They're not just making a mistake. Okay, got it. Also, the inverse square law is a consequence of relativity. It's not a consequence. It's the silliest thing ever stated. It's clearly a mechanism that works in all of Maxwell's equations. It happens with light bulbs. You think you need relativity to make a light bulb in the inverse square law, you fucking idiot? No, it's what happens when point sources radiate a force of any kind, radiate anything as rays. You dumbass. Really stupid fuck. All right. Consequence of relativity when you're not moving fast. So no contradiction. All right. So let's see. Also, the inverse square law is a consequence of relativity when you're not moving fast. So why is it that the inverse square law, the photons coming from a light bulb create the inverse square law? They don't have to behave, they're not being affected by it. They're actually creating an inverse square law. They're doing this. See, hands 4 times smaller, half the distance, 4 times bigger. That's not relativity, asshole. So no contradictions. You're an idiot. You apply the geodesic equation and derive the path of the photon. And again, I'm saying that you can't bend light more in less gravity. So you explain to me how the less gravity bends the light more than the more gravity. Lots of contradictions, I'm afraid. How can you malign physicists like this, then turn around and criticize the aura? Oh, yes, I'm calling them knuckle draggers by saying I don't think this lens is the same as a concave lens. I just called him a knuckle dragger by saying I don't think so. You're an amazing idiot. Anyway, our Mali's Mathers for calling Einstein an idiot. Well, I never bothered. Somebody can call Einstein an idiot. That's not so bad. But whatever. I don't waste my time doing it. You are maligning them. You don't know that. You're maligning me. You don't know that. You just said that I'm deliberately doing something, okay, that I know I'm not doing. So I know it's a false accusation. You are deliberately misconstruing what scientists say happens. I honestly stated that every video I watch, they always have the light going diverging and then converging. Every single one. You don't think that's an honest statement? I've never seen that shaped lens. So this website was the first I've ever seen of anything ever written on the subject of lensing where they actually used a lens almost the right shape. And again, it's not the right shape because they destroyed the inverse square law. You're such an asshole. Anyway. So Linda, that lens shape, the picture you showed, bends towards inward more when the light ray is closer to the middle. Yes, less on the outside. Yeah, that's a real problem. And it managed to create stretch blobs plus rings. So again, I showed the galactic images. You can see the little dots, that they're galaxies. It's not a blob, okay? It's not a distortion of pixels from all kinds of different places or anything like that. So it's an image. It's a distorted image, but it's an image, just like you would have enlarged it. It's an image. All right. Anyway, also, why wouldn't light be affected by gravity in your system? Because forces aren't affected by forces, and light's a force. So that would be why. It makes no sense. That's why. You can't shoot a laser beam into a laser beam and make the light photons bounce off of each other. That's the reason. And the force of gravity is no different than the laser beam. It's a force. It can't affect a photon. Anything to your light is particles. According to you, light is particles. So why the inconsistency? Well, there's never been any inconsistency. I've stated from the very beginning, and I've explained why. Because of this kinetic problem. If these two pens were red and I bang them into each other, right? How would you know whether they hit each other? Are they reflected? Right? How would you know? Or they went through each other. So you got 3 choices. They can go through each other, they can reflect off of each other, or they can miss each other. Now, if they were the same color, how could you tell? Oh, that's right. You couldn't. Yeah, right. So it's only if they're different you could tell if they reflect. Right? Now, going through and missing, you couldn't tell the difference between going through and missing, but you can certainly tell reflections. And so the point is if the form of energy is the same, photons are all one kind of energy. So they're all blue, let's say. So you'll never tell when they hit each other. So it's irrelevant whether they hit each other because you can't tell when they do. One photon, one's going this way and one's going that way. Whether they hit each other, they don't. That's what the end result is. So that's my reasoning, idiot, asshole, fuckhead. All right. Mr. Roberto, he says force can't interact with force in his theory. See, now I'm just saying it can interact in ways you could never detect. So that's the point. It can't interact in ways you can detect. So what I'm saying is that the proton force can't hit the electron force. The only way that can happen is it has to go through a matter bit. So it has to go through a proton or an electron for these two forces to exchange their direction. For the red pen, the blue pen to go this way, and for the red pen to go this way. It has to hit a matter bit to translate between these two. So they're on different dimensions, you could say, and they can never hit each other, the different colored bits. And the only way they can hit each other is when they hit a matter bit, is then they can exchange. And that's when the universe changes. And that's the whole game. So I don't, it's probably saying too much to say force doesn't interact with force. Force of the same polarization can't affect force of the same polarization. I don't know if that's even the right way to say it. Yeah, it probably is the safest way to say it. It can't affect it. Can't change the universe. The interaction looks the same as the non-interaction. So if there are interactions, it just doesn't matter. All right, anyway, there isn't a focal point because the light near the mass bends more than less. So that makes a lot of sense. Because the light near the mass bends more rather than less. Yes, that's exactly my point. So there's no way to focus. So there's no way to collect a group of stars in an image, a galaxy. The appearance of the galaxy can't possibly be transmitted through the process because the light that needs to be bent more is bent less, and the light that needs to be bent less is bent more. A regular convex lens does the opposite, but it still bends inward, and there's a focal line. Says you. So again, you're saying that bending too much. I'm just saying that you're saying the divergence that's going out this way when you're magnifying an image can somehow be fixed, not by bending the light on the outside more, but by bending the light on the outside less and bending the light on the inside more. And I'm saying, how could that possibly ever work? Whereas a concave lens bends light outward, not what you'd expect from gravity. Well, I'm just saying it's the rules. So again, I didn't make the rules. Gravity works that way. Not that complicated, he said. So how is he doing this? How is he perverting this to now claim this lens doesn't collect light coming at divergent angles and bend the light more on the outside and less on the inside, even on this section of it? It would be bending more, you know. Anyway, there's no point. Linda, does force interact with force in his theory? Not in a way you could see. He says all matter is made of force caught in loops. So loops, he puts in quotes. I've used things like the idea of squares, but I've called them traps, like ping pong paddles. and the force is trapped going back and forth, back and forth. And if you have a proton, then it can be trapped going this way, back and forth, back and forth, back and forth. Yeah. Traps. But whatever. Yeah, that's another contradiction. So no contradiction. The force is bouncing off of matter. The force interacts with matter. The force doesn't interact with force. Photons don't hit photons. Photons hit electrons. You understand that part? Shit for brain. Also, red and blue force does bounce perpendicular. Well, I mean, it's a simple principle. That's what charge is. Charge means that the one particle is affected by, the red one comes into the proton and it reflects off of it. But the blue one comes into the proton and it comes out perpendicularly. Oh, that's too complicated a rule. Too many moving parts. So two kinds of force and protons and electrons. Too much, too complicated for you. You can't follow along. Oh, okay. That sounds like force interacting with force to me. So again, just an insanely stupid point. As I've made it clear over and over and over. Electron force, proton force, electron, proton. Matter bits, force bits. Stuff moving the speed of light is not matter. Stuff not moving the speed of light is matter. Stupid asshole. I'm honestly trying to give the benefit of the doubt on that aspect. I don't know. I don't need any benefit of the doubt. I mean, I've made it pretty clear. And people going to just say you're too stupid to follow along? I mean, you don't understand this analogy? If these two pens are the same color and there's only two reactions, missing and reflecting, you do understand that you couldn't tell the difference. Right? You do understand if they were both red, you couldn't tell whether they hit each other or they missed each other. You can get that, can't you? And you can understand that if they are a different color, and I have two of them intersect, and they're going to exchange momentums, that, hey, that is a change in the universe. Because the other universe had a blue thing going this way and had a red thing going this way. And now the universe has a blue thing going this way and a red thing going that way. And that's a change in the universe. Fucks. Mr. Roberto, pretty sure the theory states that force doesn't interact with force. Again, let me just restate it. It doesn't interact in any way we could ever detect. Okay, so if it interacts, it does it in a manner where it changes the universe zero. Zero change to the universe. I think if you press him, he'd say that there is a distinction between matter bits and force bits. Yeah, like a gigantic one. Like that's why one's called force and one's called matter, is because they're not the fucking same thing. Yay! Oh, amazing. Prepare for trouble in capitals. I don't know what that's for. Make it double. I don't know what that is. To protect the world from devastation. These people are wasting time, I guess. To unite the people within our nation. Okay, we'll just delete this guy. Okay. Time waster for me, anyway. I guess this Jesse guy can go too. I don't know what these two are about. Jesse and James. They're just so cute. Like a puddle of diarrhea. Yeah, it should be hunted down and killed. All right. The world deserves devastation. Whatever, that's just totally irrelevant. What the hell happened? Oh, it always jumps. What the fuck happened here? All right, nope, wrong. Acknowledge that. Meow. No, that's not it. Okay, there we go. Meow. That's right. Okay, we'll get rid of that one too. Just because, I don't know. Fuck, these people are just too fucking. I don't know. Google should just not let people do this, waste people's time shit. To the people saying force doesn't interact with force. Oh, now there's people saying it. Cool. I get that Gary said that. What I'm saying is that this is an inconsistent. that this is inconsistent logically with everything else he said about matter made of light. So again, in absolutely no way is it inconsistent. The point is the electron and the proton are the fundamental elemental matter bits, and the force between the electrons and the protons. Electron and electron is where the electromagnetic spectrum is trapped. That's where the photons are created. And proton, there's no spectrum, but that also has its pressure, and that's why their protons are pressurized. But that's where all the pressure comes from. The force trapped between the bits of matter. The magnetic monopoles. That's what the electron and the proton are. The magnetic monopoles. Oh, this is good. I mean, I got lots to go here. Anyway, so yeah. What I'm saying, okay, inconsistent. Okay, so acknowledge that. No, why should anybody acknowledge that? There's no inconsistency at all. I've never stated that photons bounce off of photons, or that gravitons bounce over gravitons, or that magnetons bounce off of magnetons. I've never stated it. I've never made any, no one could imply that I've ever said it. I've always made it clear to talk about it. And I've even, it's even words they use like, what's that stupid word for when, the word they use, superposition. Superposition in its original meaning used to be exactly this consequence, that two charges don't affect each other's force. They can't bounce off of the force. They have to actually have their force affect the other object, the other magnet, or the other charged element, or this force has to reach the other thing. The forces have to get to the matter. The forces can't bounce off of force. So the force that a magnet makes doesn't repel off the force the other magnet makes. The force actually has to go to the matter, and then it has to go to the other piece of matter to be a force. The force doesn't have any meaning until it finds an electron or a proton. Force can't do anything until it finds an electron or a proton. Okay, so acknowledge that. No, fuck you. Nope, wrong answer, Gary. All right, fuck you. You can wave your hands all you want. Well, again, whatever that even means. It won't change that you're mistaken. And again, the demonstration of me being mistaken is what? That you think this lens represents gravity. That's what gravity lenses look like, if you could make one. And that's not what they look like, if you could make one. Typically, tragically, about what the case really is. Yeah, fuck you. Gary, there is no contradiction in Einstein's theory. Well, that's just a pile of shit. It's not even that there's a contradiction with logic. The non-existent bent nothing makes stuff move is a silly argument. I'm not even stating there's a contradiction. I'm saying there's no excuse to think photons aren't affected by the inverse square law. Why does the inverse square law disappear? Why does the light bulb all of a sudden create twice as much light just because I'm a photon? So if I'm an electron, no, it's just that certain amount of photons. But somehow if I'm a photon, I get extra light comes off of the light bulb. That's Einstein's stupid argument. It's stupid. All right, you are taking the word inverse square law and supposing that this is some absolute law like conservation of energy. Yes, that's right. I think it's as absolute as they come. The fact that that light bulb is producing energy at the rate of an inverse square law, that it's obeying an inverse square law, the amount of light the photons will hit me will obey the inverse square law. That is, if I have the distance, I'll get 4 times more photons will hit my hand. It's doing exactly what gravity would be doing in reverse. And it's a law until you get very close, as I've explained. The inverse square law breaks down as soon as you get very close. And the point is that At a distance, things are like points. So they're like little tiny specks. But as you bring things closer, then it's a bunch of points on a surface. And so if these were like two charged plates at a distance, the inverse square law will be in effect. But as you bring them closer, then all of a sudden, the little angles that the divergence from each little atom inside of this pen and this pen, all of these elements are diverging, but none of that divergence is missing the other pen. So if they were emitting light, this wouldn't be the inverse square law. The light would be hitting both of these objects at the r rate, not at the r squared rate when they're this close, because all the angles still hit the other object. All right. So you're an idiot. So anyway, okay. Yes, it is just, yes, it's the inverse square law is just as, the only way you get around it is, like I said, in this technical argument where the point sources, you end up creating an infinite plane in a sense, because things are close enough that from an atom's perspective, there's an infinite number of opposite elements. When in reality, it's Newtonian, which is, which relatively replaced. So again, he thinks that you undo Newton with Einstein, where Einstein undoes nothing that Newton said, and it's just garbage. Because Newton didn't say anything. He just said, yes, look, it's quite obvious the force emanates at this inverse square law. And that's about all Newton said. Not that complicated. And that the force is related to how dense the collection of weight is in terms of creating gravity. You can't acknowledge that. Why would I acknowledge anything? Like I said, I think it's Newtonian, which relatively replaced genius. So again, first off, I don't think it replaced anything. It just added something. And what it added in the math, it could be argued that the math is just Maxwellian math, and that it's basically just doing induction. So all Einstein did was add induction to the theory of gravity and a speed with which the force is induced. So it perfectly fits with my argument. When objects travel fast, they undergo time dilation in Einstein's theory. Well, again, says you. And again, when objects travel fast, I would argue they go through degrade. They start to fall apart. And you can think that's time dilation, but I think that's just falling apart. And you still have no evidence that time dilates at any kind of proportional curve or anything. You've never sped a person up to half the speed of light. I would argue the person won't survive. Therefore, the light bends more, no contradiction. Well, again, that doesn't make any sense to me. So there's no contradiction. The light bulb creates light. And because I think I was in the light twice as long. Now we know how long the thing is in the light, right? It's 1 second from one side to the other. The argument is if I'm moving really fast, I'll think the 1 second is 2 seconds. But it doesn't change the fact that it was actually only 1 second. I mean, it's my perception that's broken, not physical reality. So again, to the people who keep arguing that Gary keeps saying that a frame is a real thing. We're not saying a frame is a real thing. Well, obviously you're saying it's a real thing because you're saying something real happens in the frame. That is, it collects twice as much light. That physically twice more photons were created to hit the spaceship going twice the speed of light. I mean, 99% of the speed of light. So if I make a spaceship that goes 99% of the speed of light, it will get hit by twice as much light magically. By going really fast, it means it gets twice as many photons to hit it. And you say that makes sense. I say it's a pile of shit. All right, you have to make a distinction between matter and force bits in addition to color distinction. Yes, and the color just represents a kind of polarization. It's really just representing charge. So color is just a way of saying charge. Red, black, north, south, however you want to distinguish the difference in the polarity. Have you looked into the physicist Sean Carroll? I mean, amazing. You know, just 6 videos ago, I played his retarded video. Damn, I can send you his latest publication, The Big Picture, if you want. No, no, fuck him. It's an idiot. He has already looked into Sean Carroll. The universe is based entirely on fermions, who cares, and bosons. Yeah, it says you. So this is just more crap. I mean, more declarations from the wrong answer. So you might as well be just saying, you know, God says that the Holy Ghost and Jesus are controlling the universe, and that's the way it is. God says so. I mean, it's just, you know, fuck you. His book explains quantum equations thoroughly. Well, how exciting. Does he explain why the pattern in photons of the double slit experiment doesn't match the math? That is, the photons don't create nice gradual light dark pattern. They create solid bars. Does he explain that? Does he explain how diffraction gradients can be used to create beam splitters when they basically diverge the light? That is, one path of the light will be completely different than the other path of the light. Does he explain that? Does he explain why photons are in the gravity twice as long because they're going the speed of light? Why there's more light created because a photon thinks it was in it longer? I bet he doesn't explain any of that. Higgs, dark matter, dark energy are all fictional. Well, they're all under evidenced, incredibly under evidenced. But that's an argument you can't make, right? You can't just say it's weak evidence because they won't admit it. No, it's the greatest evidence ever. Everybody should believe it, or else we'll mock you. All right. No dark matter. Please explain the expanding universe. No, all you have to do is explain redshift. Okay, you haven't proven the universe is expanding. All you have evidence of is that the light off of an awful lot of the matter in the universe appears to be redshifted, which means we are moving away from it, or it's moving away from us, but something's moving away from something. But that's all. 70% of all matter is dark matter. Yes, mush. I do not believe the universe is expanding at all. I don't know. I can't say it's not expanding, but the argument would be if it's expanding and losing photons. So let's just understand there's two things happening. Let's say it's expanding, and at the same time, there's a bunch of photons leaving the universe, right? All the light that goes out of the stuff that goes where there isn't any universe from the Big Bang. So we're saying the universe is some consolidated thing, you know, that it's something that went from this to some other shape, but it's still a shape. Well, that shape is radiating light out of its shape. It's leaving the shape. So if it's expanding and radiating, effectively mass, the light is mass, then yeah, it's going to fall apart. It can't possibly recontract, right? So yeah, so yes, it will die a slow, cold death. But who cares? I mean, I don't think this is important speculation myself, but go ahead, play with that nonsense all you want. Let's see. Didn't you say the photon is made of matter bits? Are you insane? What? Oh, the proton. The proton is a matter bit. It's not made of matter bits. A neutron is made of a proton and an electron. But the proton is a proton and the electron is the electron. They're elemental. Now, they might be made out of quarks or some other kind of crap, but I'm just saying they're so elemental that whatever they're made of can't survive in the universe for more than a zillionth of a second. So whatever they are, they're pretty solid. And I would argue that all the same ones that were around when the dinosaurs were roaming the earth, it's pretty much all the same protons and electrons that were moving around then are still here now. There hasn't been a whole bunch of new ones made or a whole bunch of old ones destroyed. All right. Didn't you say the proton is made of matter bits? No, not even close. Or is the proton itself a fundamental particle in the model? Well, I'm just saying, I mean, it's so simple. Positive charge, negative charge. Got it? Positive, well, here, positive red, negative blue. Now, so this would be electron, matter bit. Proton, matter bit. So you got negative and positive matter bit. Now you have force bits, same colors. Okay, electron matter bit, force bit, proton force bit. And that's all. That's all there is. So there's this stuff moving the speed of light, the force bits. It's polarized. The matter bits don't move a particular speed. They can be pushed, but they have to be pushed. And they're polarized, the same colors. The force bits reflect off the matter bits. Yeah. That's how they get trapped. They get stuck between them. The matter bits are ping pong paddles. Okay, the elemental matter bits. Protons and electrons are ping pong paddles. And the balls are what goes between the paddles. Okay. Anyway. Or is the proton itself fundamental? Yes. Used to say that the proton is a body of bits held together by outside pressure. I would still argue it's likely made out of the force. Okay, but I don't need to argue that far, right? So it's, yes, yeah, I would argue that it's probably made out of force bits, compressed, but it just doesn't matter to the theory. So why play with it? 99.99% of matter in the universe is ionized gas. That's very exciting. Dark matter is 100% fictional with no evidence supporting its supposed existence. Well, I don't know if you could necessarily prove prove, okay, that 99.99% of the matter in the universe is ionized gas either, but whatever. 68 kilometers per second per megaparsec. Well, not very exciting, whatever that was for. Why are these galaxy clusters, superclusters, large-scale structures, etc., if galaxies are moving apart? How can some far-away gases be blue-shifted if this is true? No expansion. Yeah, well, the blue shift stuff does make you wonder. And why are the lensed images always blue shifted? Isn't that a curiosity? The matter we see only makes you 5% of the total matter within the universe. So again, it doesn't make any sense because the only way dark matter works is they have to selectively place it. So understand, when they talk about dark matter around a galaxy, they place it out here. So there's a ring of dark matter out here. There's not like a whole bunch of it here in the middle. So they place it in any location they want to, and in places it can't possibly exist in because it's still gravitational. So they're almost arguing that the dark matter makes gravity, but it somehow isn't affected by gravity. Now, isn't that a catch-22? I mean, a perfect catch-22 kind of pile of crap. Not only is it invisible, magically invisible, but it's also, you know, I don't even know how to even say it, right? I mean, it makes a force that it's not affected by. I mean, come on. It emanates something that it can't respond to when something else animates it. I mean, come on. He just said it's an absolute law, and now he says there's an exception. I'm like, yeah, I made the point that it's for all intents purposes, the inverse square law is solid once you're a couple of millimeters apart or something. So only in extreme cases where you get things really, really close that it doesn't apply. But in every other case, it applies quite consistently. So yes, it's a very reliable fact. The gravity is a very reliable thing. I mean, that's why we landed on the moon. I guess you're one of those people. We didn't actually land on the moon because we couldn't figure out what the gravity is to get off of Earth and then to get to the moon and to land on the moon and then to leave the moon. Because somehow it doesn't match these absolute laws. Of course it does. Let's see. He just said it's an absolute law, and now he says there's an exception. So again, I didn't say those in separate sentences. I said those right in the same sentence. And I qualified the statement that it's rock solid anywhere but really close. That's the only exception. So what? It's still not a law? I don't understand. Something happens and it has one condition, and therefore you don't talk about how it happens quite regularly and how it's a solid principle just because it changes slightly in one circumstance, and you articulate the one circumstance for which it changes. I mean, what a stupid standard. I mean, I could come up with some example where, you could have an absolute law, but it only applies to women because only women have breasts or something. Galaxies are clustered together, no moving apart. That's an open question of what galaxies are doing. Whether they're collecting matter or expelling matter is, in my opinion, an open question. I think you're referring to Andromeda Galaxy. Most are redshifted. Regardless, you still have to explain, we don't even know, you people don't even know what photons are, yet what creates redshift. I mean, I've made the argument, but what exactly would horizontal motion, not horizontal, but perpendicular to your field of view, what would that do to the photons being produced by the object? Does it count as movement towards? Because clearly it has an element of towards, right? If an object's over here, it's further away. This diagonal's further away from me than this straight line in front of me. So clearly, if it's coming from a distant place and it's moving towards me, it would end up having a blue shift, right? And likewise going away the other way, a red shift. So I'm just saying there's lots of complexities to this whole red shift, blue shift thing that I don't think have been hashed out enough to say you are certain the universe is expanding. I don't think you have good reason to be certain. I think you're referring, okay, I understand that the conventional theory requires 90% plus of the universe to be new, invented, exotic magic stuff, but I believe that once the model is falsified, it is false. I'm just saying that it doesn't have any evidence supporting it besides circumstantial evidence, and even that is silly. Again, I mean, it's silly to say, well, our math was broken, okay, and the galaxy, the stuff on the outside was moving too fast, so we'll make the stuff move too fast by putting dark matter next to it. I mean, that just all looks like contrived. That's not even circular logic. That's just contrived. Okay, that's just, we made it. We put dots and then connected them. I mean, we couldn't make our dots connect into any good pictures, so we just put some new dots in so we could draw Donald Duck. I mean, it's just made up physics. Yeah. You don't get to invent magic particles to fix broken theories in science. Well, you shouldn't be able to, but of course they are allowed to do that. How can there be clusters and superclusters if most galaxies are moving apart? Think about it. Galaxies have to be moving towards each other to form clusters. It depends on no, I mean, again, everything could be moving apart because the galaxies could be expelling. It's all losing pressure. It's all falling apart. Falling apart means you do get bigger. You go from high pressure consolidated to I'm getting, less and less dense. So you get bigger and bigger and bigger as you start falling apart. Each galaxy has its own particular motion, irrespective of the Hubble expansion. Well, I don't know if that motion matters. Most are redshifted. I suppose it's good to get a more detailed knowledge of that, because I don't know exactly how many are, what's the percentage exactly, and that's sort of, we should know those facts as context to that conversation. The spectra of most faraway galaxies are redshifted. This doesn't mean that space is stretching out. Well, it's like I said, redshift has an implication. Something has to be moving. Are you saying that the time dilation formula has no evidence? I'm saying that time dilation is just a relationship between velocity and a degrade in clocks, and that you can't make more photons with it. All you can do is misperceive time. Okay, your scale breaks. You can't change what took place in the period of time. So if a rocket ship is flying through a certain amount of space, and that space creates a certain number of photons for over a certain period of time, because you think it feels like it took 2 hours instead of 1 hour, you're not allowed to say, because it feels like it took 2 hours instead of 1 hour, I got hit with twice as many photons. It's the argument is like, if I'm time dilated and my clock is running slower, right, and I'm aging slower, it doesn't mean that I live more than 100 years. Let's say if I was going to live to be 100 years old, I still only have 100 years of experiences, even though the people I left have 1,000 years of experiences. It doesn't change the fact that I feel like it was only 100 years. The truth is, it still was 1,000 years, whatever the number was. You can't change the physical reality because you feel differently. For fuck's sake. All right. So are you saying that the time dilation formula has no evidence? So we put formula in capital letters. So that's something to keep track of. I'm saying the causes are what's always suspect here first. The mathematics isn't what's being critiqued. What's being stated as the cause for the relationships that exist is what's being argued. And I'm saying the cause of time dilation, the degrade in the performance of matter, the fact that the radioactive isotope decays slower as you move it faster, is a physical phenomenon. Time didn't change. The inside of the atom changed. It functions differently when you move it because it has force in it. Okay, gravity is binding the galaxies into clusters from close proximity. Yeah, well, again, I find it a little difficult to believe that galaxies are Well, it doesn't matter. I see this part just doesn't matter. So, people can talk about it if they want to, but to me, it's not really interesting physics. But what was I going to say? Yeah, it does seem a little strange that the galaxies would be out in the universe and then cluster, right? That doesn't seem very probable. That they'd all be in some independent place making galaxies, and galaxies are made out of binary stars, and all this stuff you have to do to create a galaxy in the first place. And it seems like its mass that was like a big, super black hole, or whatever you want to say it, lots of mass in one spot, and that mass degrades and it forms galaxies as it degrades, and the galaxies are flying apart. Let's see, what do you consider close proximity? They're grouping at all scales: cluster, supercluster, walls as far out as we look. Matter is clumping together, not moving apart. Yeah, so I don't really buy that argument. There's no evidence galaxies are actually moving apart. You said it's probably made of force bits compressed. But if a proton is made of force bits compressed, then it can't interact with force. Well, obviously, when it's a matter bit, it can. So, this is just so silly. So I made the distinction. I didn't even want to bother doing it because this is the stupid games you'll play. Yeah, clearly when it's compressed, it behaves differently than when it's not compressed. So that's the argument. So if you can take the force bits and somehow smash them into a proton that isn't moving the speed of light anymore, so obviously the force has been altered in the sense that whatever speed it has, it's all doing it circularly, and it all is in balance somehow. That would function different than the free force. Just amazing. I mean, do you play these kind of word games with people who talk about quarks? Just such horse shit. All right, anyway. That's not true. It's not a ring. It just goes further out. I know what the ring thing is referenced to. There's no evidence of galaxies are actually moving apart. So that's where you guys ended. Okay. Well, that's kind of a weird ending. Too bad there's not time codes there. That's not true. It's not a ring. It just goes further out. Not a ring. I don't know what that means. Okay, so now you speculate that the non-free force can interact with the... Oh, I mean, you're just going to be just an asshole about it. I didn't want to be bothered explaining what an electron or a proton is made of, right? I said, fuck it. It just doesn't matter. It's the matter bits. It's elemental, okay? And I said, but yeah, if you want me to explain what I think, what I think, yeah, I think ultimately they probably have to be made out of force bits, okay? Because yes, you have red and blue, and the force is probably the real stuff, and everything else is just made out of force. So the matter is just a smashing of the force. It's crushed together, so it stays in a clump and it doesn't go anywhere because all the little pieces are stuck. They crossed each other and they're spinning and they're stuck, but you can still push it, in a direction. But I don't need to go into all that detail to make the argument. And it can only be my speculation. There can be absolutely no derived evidence of the insides of an electron, for fuck's sake. Oh, Jesus. You people are just so pathetic. It happens like this. People just keep asking stupid questions. Well, who created? Where did the electrons come from? Where did the protons come from? Like somebody's supposed to answer idiotic questions like that. Yes, where did the elemental bits come from? They think that's physics. Yeah. Even this whole speculation about whether the universe is expanding or the universe is contracting, who the fuck cares? Whether there was a Big Bang, there wasn't a Big Bang, who cares? It's not really physics. I mean, in a lot of ways, because there's, you're never going to have good evidence. I didn't say you asked. I said in the conversation it came up. You're not the only player here. Somewhere in the conversation it came up. Somebody said something. I said, okay, well, if I was going to say what the basic elements are, I'm going to say that, yeah, they're, the electron, the proton are made out of something, and they're going to be made out of force. You're not regurgitating what I'm saying, obviously. I mean, obviously, you pay no attention to the context or the fact that I overtly said that, yeah, if there was a trapped bits and there were untrapped bits, those would be very different bits. Why is that a big contradiction? Why is that hard to figure out? Oh, yeah, they'd be different. I mean, I could give examples of the difference between ice and liquid water. Yeah, okay, it's H2O. It's the same stuff, but clearly it's different when it's in the frozen form than when it's in the liquid form. If I hit you with a pound of frozen water, versus liquid water, you'd know the fucking difference. Yes, and it's not controversial to say that it would require a new mechanism by which the compressed ones interact with the free force bits. Yes, and it could be a simple mechanism, nothing very complicated. Again, I've made the argument that it's this dimensional thing, right? The two forces likely don't move in the same dimensional space. That is, the two forces could never hit each other because they are on different levels in the three-dimensional matrix. So their lines don't intersect. But when you make a matter bit, that is, you compress the force, then it squeezes into the dimension of the other stuff, and that's what creates the mechanism for the two interacting and creating the perpendicular interaction. So yeah, it could be a very simple mechanical explanation. It could be as simple as an arrowhead. If I put an arrowhead on these pens, well, they always already have, you could sort of see that if the two arrowheads miss, they'll bounce off of each other and they can create a 90-degree turn that way. It could be a very simple mechanism. Again, it's not significant. This isn't an important part of the theory. And you're using this argument to say, well, these explanations are made up and these explanations aren't blah, 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 and they're not considered. Yeah, this has nothing to do with the fucking subject of conventional wacky theory compared to my mechanical theory. You don't ask any of these questions of bent space. Well, how does the bent space work? Where does it get its energy from? How does it pull things in with no energy and no strings and no arms to pull with? And how does it do that? No, you don't ask a single fucking question. I mean, it would require a new mechanism. It's just so funny. You haven't required the current physics to give you any mechanism. You ask zero of their mechanism. Don't give me a mechanism. Just say it obeys the inverse square law. There, we're done. That's all Einstein did. He said it moves the speed of light, it obeys the inverse square law, and it involves induction. That is the center of gravity's move. Nothing, no mechanism. He just tells you what it does. He doesn't tell you how it does it at all. So anyway, plowing into a couple hours, no doubt. So looks like it's wound down enough and such. So I guess I'll say good night. And yeah, that's what I'll do. Yeah. Okay. And so yeah, probably maybe around 10 o'clock I'll do a room on this. I'm not as sure I will now, just because I just killed 2 hours in this room. I don't know if it was very productive, but anyway, we'll see how it goes. So till the next time and such, so forth and whatnot. Unless you have anything else. Well, likewise and such and so forth. And get what you deserve. Yeah. Just get what you deserve. This is a great thing to say to somebody. Get what you deserve. I love that. At least for the good folks, they'll be like, I deserve something good because I do good. All the shitheads will say, oh, fuck, that's a nasty thing to say. Yes, I'm a selfish cunt and I deserve to be abused and exploited. Anyway, so till next time. Such. Yeah, I mean it this time.